Hello guys, today we're going to study 5.3 partial fractions. In the past we had to learn something like this. If we have a given 3 over x minus 4 minus 2 over x plus 2, so we can find the common denominator here, which is x minus 4 times x plus 2. Then we do a distribution, and then we collect like terms, then we find the x plus 14 over x minus 4 and x plus 2. Okay, and this is our solution. Today, what we're reverse is the process. So basically what you have is, we're going to have x plus 14 over x minus 4 times x plus 2. And then from here, so we're going to somehow to get 3 over x minus 4 plus negative 2 over x plus 2. So we have on the right hand side, we say this is the partial fraction decomposition of the x plus 14 over x minus 4 times x plus 2. So each right here is 3 over x minus 4, that's our partial fraction, then plus another partial fraction. So I hopefully you also find this math joke is funny for you. Okay, case 1. Okay, if you look at this, it seems complicated. Let me just explain really quickly. Okay, case 1 is the partial fraction decomposition of p of x over q of x. Alright, so when we're talking about p of x, q of x, it's just a polynomial. Okay, and then we say the q of x, which is the denominator, has a distinct linear factor. I highlight over here, distinct linear factor. When we talk about linear, which means it's a straight line, and then we have a x. There's no x squared. So if we have a p of x over this whole thing, a sub 1 x plus b sub 1 and times a sub 2 x plus b sub 2, and then so go on. Okay, if we have this case where our a sub 1, b sub 1, all these, they're just some constant. So then if we're given something like this, then we're going to equal to the capital A sub 1 over, okay, a sub 1 x plus the b sub 1. So if you look, all we're doing is here, we're turning into a denominator, and then with the second one, that will be plus a sub 2. Okay, the second piece is from here, right? And then you're doing the same thing, and then third piece, add the third piece from here. Okay, and then where our letter just goes on. So in the past, I have some student ask me, why don't you use A, B, C, D? If you think about it, A, B, C, D, we only have a total alphabet. We have 26 of them. So we're talking about this actually go on forever. That's why we have A sub 1, A sub 2, A sub 3, goes on. Okay, let's just see how we use this case 1 to solve this example 1. So example 1, find the partial fraction decomposition of x plus 14 over x minus 4 times x plus 2. So I'm going to rewrite this as x plus 14 and then over x minus 4 times x plus 2. So we have to look at this. Okay, look at the denominator. So x minus 4, I want you to go ahead to only look inside the parenthesis. Okay, x minus 4, that is a linear factor because we only have x. We don't have x squared, that would be quadratic. We don't have a x to the third power. So we only have a x minus 4, that's a straight line, that's a linear factor. Same thing as second part, x plus 2, that's also linear factor. That's why we can satisfy this case 1. We can set up this equal to a over, okay, let's look at this. We had a pink color for the first. Okay, first piece, I'm just matching the same color as your formula right here. So I'm going to write down this right below it. Or I'm going to write down here, x minus 4. Okay, and then instead of using a sub 1, we're just going to use letter A. Okay, so distinguish them more easily. And then we can use letter B for the second part, which we use the green color. Let's go ahead and continue to use green color. So that will be x plus 2. And then we're going to solve for our AB. Let's see how we solve this. The next step we're going to do is whatever is this denominator, okay, you're going to use this multiply every single term. So let's go ahead and write them down. Alright, so we'll just multiply this every single term. So now we're going to start clean this up a little bit. So if you look right here, x minus 4, x plus 2, we're just going to be canceled out, right? So the only thing left is x plus 14. And then equal to here, a over x minus 4, so x minus 4 are going to be canceled out. We're going to have a times x plus 2. And the same thing happens here, the last term, b over x plus 2. So x plus 2 cancel out. We're going to have a b times x minus 4 left. So we're going to leave the left side alone. So we're going to do a distribution. So then we're going to have ax plus 2a, then plus bx minus 4b. I'm continuing to leave left side alone. So what I'm going to do is I'm going to collect the left term. So that is my x, that is my x. I'm put them together, that will be x plus b x. And then we're also going to collect the constant together, because we know the part is our a and b just some constant. So we're going to put them together, which means we're going to have here, alright, 2a and a minus 4b. So put them together, that will be 2a minus 4b. I'm going to use the green color for this. Now we're going to look at the left side, and we also look at the right hand side. So if you can think on the left hand side of x, what is the coefficient for our x? It actually just going to be 1, because that's the invisible 1 right there. So now we can write it down, because if I'm going to compare this left and right, what happens here is if the coefficient on the left side is a 1, we know it's an equal sign here. If they're equal to each other, then we say this must be true. 1 must be equal to a plus b. And then we also look at 14. That's our constant. We said on the right hand side 2a minus 4b. That should be equal to 14. So that will be 2a minus 4b. Now we actually just set it up as a system equation with two variables. So we can actually solve this, right? So instead of writing 1 equal to a plus b, I'm going to rewrite this as a plus b equal to 1. And then 2a minus 4b equal to 14. So from here, we can just solve it as a system equation. You can use any method to do this, okay? We're going to do this really quick with a substitution, all right? So I'm going to do a substitution. That will be a equal to, all right, 1 minus b. And then we're going to bring this to the second equation here. That will be 2 times 1 minus b minus 4b equal to 14. Distribution, 2 minus 2b minus 4b equal to 14. So that will be negative 6b equal to 12, b equal to negative 2. Okay, once we have this, we'll bring this to here. That will be a equal to 1 minus negative 2, which is 3. So we solved our a right here. Our a give it to us is 3, and then b is negative 2. Again, this process, you can use any method. You can even use a matrix to do this if you want to, whatever you choose, okay? So once we have this, we're going to write down our final answer. We're going to bring this 3 all the way back. So that 3, we're going to bring this all the way back. Maybe I can do this, all right, to here, okay, where we set it up. Then we do the same thing for our b. We're going to bring this b to all the way here. All right, if you want me to do another line, I could. We can do it right here. Okay, so we'll do a substitution, and then we're going to write down our final answer. Our final answer is going to be x plus 14 over x minus 14, x plus 2 equal to a, we said is 3 over x minus 4 plus b is negative 2 over x plus 2. Okay, you can also write this just minus 2 over x plus 2 as well. Alright guys, that is your final answer. Okay, that is our case 1. So take a deep breath and then go back and check again. Pause the video if you kind of not understand something. Just pause it and think and then try it. Okay? Alright, let's go ahead and work on case 2. So here we have a case 2. So the partial fraction decomposition of P of x over Q of x. The Q of x has repeated linear factors. Okay? Think this again. Repeated linear factor. What that is if we have a P of x over ax plus b to the nth power. Repeated. Now maybe I can highlight this word. So this repeated, that's what we're talking about, this n right here. Okay? Outside the parenthesis is n there. The inside the parenthesis we still have x. Still is a linear factor. So that is what we're talking about. So if we have P of x over ax plus b, this whole thing to the nth power, then we're going to have equal to a sub 1 over ax plus b. Okay? That's the same thing as we have this whole thing to the first power. Okay? Then plus a sub 2 over ax plus b to the second power. Okay? First and second. And then we can go on. Then we have this whole thing denominator to the third power. Until whatever your n is, you stop there. Alright. Let's go ahead and look at example 2 and how we apply this rule. So example 2, write the partial fraction decomposition for the following rational expression. So here we have x squared minus 7x plus 6 over x minus 3 to the third power. We look at this. First we're always going to look at the denominator. Okay? The denominator is x minus 3. We look at inside the parenthesis. Inside the parenthesis, we have a linear because it's x minus 3 is only first power. We have a straight line. And then we look at outside the parenthesis. That's where we find this is repeated because we said outside that is repeated. Okay? So now we're going to set this up. We're going to set this up by using the formula above. We're going to write a over, we set the parenthesis. Okay, this is a pink color, so we're just going to write this down. Then we set this to the first power, right? And then we're doing the same thing. And then we have a b, there's a whole thing, parenthesis. Okay, I'm going to fill that in just a second. To the second power. And then we have this is c over, there's a whole thing to the third power. And then we match this. Once we hit this 3, because our n in this case is the 3, we're going to stop right there. Okay, that's how it works. So let's go ahead just to fill it in the denominator. Okay, so make sure you understand this. Okay, the setting up part is the hardest part. Now we're going to try to solve what is our ABC. So let's go ahead and do this. Okay, we said whatever is the denominator right here, this case, then we're going to use that multiply every single term, right? So we're going to do this very quickly. Alright guys, I just multiplied every single term. Now we're going to simplify. Okay, so we know the whole thing going to be cancelled. So we're going to have x squared minus 7x plus 6. And then we have the second one. So we have, this is the first power, this is third power. Basically you have a second power left, right? So that will be 8 times x minus 3 to the second power, and then plus b times, so we have the denominator, if you are not used to it, okay, denominator is x minus 3 to the second power, to multiply this whole thing to the third power, that will be x minus 3 left. And then the third term we're going to have a c, okay, they're going to be complete, cancel out, so we're just going to plus c. We said we're going to leave left side alone, so then we're going to expand the right hand side. It take a little bit time, but make sure you be patient and then do this. Okay, so that means it's 8 times we have x minus 3 squared. Okay, if you want to do, you can use this a minus b squared and then equal to a squared minus 2ab plus b squared, or some of you guys like to use the FOIL method, you can do that too. So we're gonna have this as x squared minus 6x plus 9. So write this down over here. That will be x squared minus 6x plus 9. And the next term, we're going to do a distribution. That will be bx minus 3b plus c. And then now we're going to do distribution here. Again, we'll leave the left side alone. We don't do anything. And then that will be a to the x squared minus 6ax plus 9a plus bx minus 3b plus c. Okay? Again, take your time and be patient. Now, we're going to collect the like terms. Okay? So x squared, there's nothing we can collect. We're just going to have ax squared. Now we're going to look in x. So we have x here. We also have x over there. So we put them together. That will be plus negative 6a plus b, and then write down times x. Our a, b, c, just some constant. Now we're just going to group them together. That will be 9a minus 3b and plus c. Okay, so that is the part where you just group them together. Okay, put the parenthesis right there. Then now we compare this to the left side. If you look at the left side, again, right here, we have an invisible 1. So I can compare this. We have 1, we have an a. So I can set them equal to each other. Okay? Because we're compare them together. Maybe I use the red color here. So here we have x squared, we have x squared. So I can set them the coefficient equal to each other. That will be 1 equal to a. And then let's go ahead continue. And then we have negative 7. That's the coefficient for our x. And then we're going to set this equal to negative 6a plus b. And then we do the same thing. Our constant 6, I can set this up as 9a minus 3b and plus c. So I want you to go ahead, take your time to solve this by using any method. Or we can just plug it in really quick. Alright, we'll bring the a is 1. So that will be negative 7 equals negative 6 times 1 plus b. And then from here, okay, that will be negative 7 plus 6 equal to b, which give our b equal to negative 1. And then we're going to plug in b for the third equation. That will be a and b. To the third equation, that will be 6 equal to 9 times a is 1, and then minus 3 times the b is negative 1, and then plus c. And then the whole thing, that will be negative 6 equal to c, right? Because the 6 minus 12 just gave you negative 6. So we found our c. So let's go ahead and write it down. Our a equal to 1, and then b equal to negative 1, and then c equal to negative 6. Right, so we can bring this back. Let's highlight this. I can bring this a to here, and then we can bring this b, negative 1, to here, and then we can bring our c, negative 6, over here. So I'm going to write the solution as, or you can bring this negative sign to the front. You could write it in this form. That will be 1 over x minus 3 minus 1, because that negative sign just bring to the front. You can write this way as well. Either way, that will count it correctly. Alright, so that is our final solution here. You can write it in either form. Example 3. Find the partial fraction decomposition of x minus 18 over x times x minus 3 and to the second power. For this question, we have to think a little bit, okay? Let's look at this denominator x. So we're talking about this one first, okay? So you can put a parenthesis if you want to, okay? Just imagine that if you put a parenthesis right there, that is a linear factor, right? Because there's no power, okay? So that is a linear factor, which is our first case because there's no repeated, because there's no power there. So which means I can use the case 1, set this part up. That will be a over x. And then now we'll look at x minus 3. Okay, look at inside the parenthesis first. That is a linear. Okay, and then we also look if there's any exponents, which is 2 right there. That means we have to use case 2. We said our case 2, I'm going to use a different, that will be b over case 2 repeated. I have to write this as x minus 3 to the first power, then plus c over x minus 3, the second power, right? Because our n is 2, so we stop right there, so that at 2 we stop. That is how we set it up. Alright, once we set up, then we can just solve it. The solving process is exactly the same. So whatever's here, we said in this case right there, we're going to use this multiply every single term. Alright, so we've done this really quickly. Again, if you're used to it, you really don't have to do this. You could just done this in your head. Okay, I'm just showing you how to do this step by step. So we're going to cancel this out. And then you're going to have x minus 18. And then we're also going to cancel here. That will be x going to be gone. So here we have a x going to be gone. So that will be 8 times x minus 3 squared. And then plus. So here a little bit tricky, okay? X minus 3. We said this is the only first power. And then here we have x minus 3 to the second power, okay? We didn't cancel out x. We're going to put the x right there. So we only have x minus 3 left. And then we're going to write down c. Here we'll cancel this out, okay? This part out. Then we're going to have a cx. And then next step, we said we're always going to leave the left side alone. Alright, and then we're going to write down 8 times. I'm just doing this in my head. And that will be x squared minus 6x and plus 9. And then we're going to have a distribution. We're going to have plus bx squared minus 3bx and then plus cx. Now we're going to continue. Distribution again. Alright, ax squared minus 6ax plus 9a plus bx squared minus 3bx and plus cx. But we're going to collect the like term now. Okay, that is the only thing left. We're almost there. So once we have this, alright, so we have to compare left to the right. So if you look at right here on the left side, we have x minus 18. We do not have x squared, right? However, we could think this way. So I could write this as 0x squared and then plus, right? Because that is just almost like a missing term. So we can just fill it with 0. So now you have this. We have x squared. So we compare the left and right, so we're going to have 0 equal to a plus b. We're doing the same thing, so here we actually have an invisible 1 right there. Okay, so we're going to write 1 equal to negative 6a minus 3b plus c. And then we have a last term. We have the last term, that will be the constant, negative 18 equal to 9a. So that is how we set up this system. Again, solve it by using any method. So since we've done this a couple of times, I'm just going to give you the answer. Okay, so we're going to have our a equal to negative 2, b equal to 2, and c equal to negative 5. That is, we find our a, b, c. And then all you have to do is, like what I mentioned before, you just have to bring this a, b, c back to here. Let me go ahead and highlight this. And then I can write my final solution, which I'm just going to write it on the top right here. X minus 18 over x times x minus 3 to the second power equal to our a is negative 2. Okay? And then we have x. And then we have a b is 2 over x minus 3 to the first power, which we don't have to write this first power. And then we can plus c, which is negative 5 over x minus 2 minus 3 to the second power. That is our final answer right there. We're going to do another video about cases 3 and 4. Thank you very much for watching the video. I'll see you guys next time.